Hello and welcome to a new video presented by Telescope-Service. My name is Thorsten and this video is an addition to our last video about the ToupTek cameras. So when we released the last video, there were questions coming up about the whole usage of the cameras, some parameters to set and all the little things that are good to know. And that's the reason why we decided to bring out this video here. I want to show you some of the insights of the camera, how to set up your PC to work with the camera, to use it in different softwares, and also how to set important parameters in that camera. Okay, let's get started with a real life example here. I have here the 2600 CP. This is a color OSC camera with an APS-C sensor. This is the Sony IMX571 sensor. That's a pretty famous one. It's used in many cameras because it's super versatile, very low noise, a big field of view, a good pixel size for many focal lengths starting from, let's say, 400 up to 1000 millimeter. Everything is possible with that camera. So pretty cool thing. And to use it, you have to connect the power supply first. And then, of course, second, the USB cable. Okay, and then you need some sort of software. I want to start with our own TS Sky software. So it's not our own, it's a ToupTek brand, of course. And it's also shipped as ToupTek Sky. For example, that's the same software, just with a different name, depending on the manufacturer where you get the camera from. And yeah, how to find the software? You just have to go to our website, look for your camera, in my case 2600 CP. There it is. And now we have linked this software with every camera. So here the first item, software TS Sky. Just download it, install it, and then you can execute TS Sky. So this is a very simple software, but you can use it for every workflow in astrophotography. That's no problem, so you can stick with the software. It features all the things you need. You have full control of the camera, exposure time, gain, binning, and so on. The cooling, the heating, everything is supported within the software, and also some more features. For example, you can use flat field correction, dark frame correction within the software when capturing. That makes things very easy. So this is also a cool software, for example, for EAA. If you want to do electronic assisted astronomy, maybe you want to show images from the sky to your friends while on the telescope. That's a cool idea to use the software. It can live stack things together, so that's pretty cool. You just have to click on the camera, it's automatically detected, so no additional drivers needed. Very important. And then you can just capture images. Of course, I have covered the camera with the rubber cap, so that's a black screen. When I remove it, then it becomes instantly white because the exposure time is way too high with a second. Oh, and the gain is cranked up fully. That's not so good. Yeah, I think you get the idea. So you see, it's nearly live. That's nearly a live view here, and we are talking about 26 megapixels that are read out here. So that's fast enough for every astro-related purpose, and pretty nice piece of software. So okay, enough of that one. If you need more of these features, then you can also try out SharpCap. SharpCap has also native support of the camera and supports also things like live stacking and all the other features, cooling, binning, exposure time control, is everything possible with SharpCap. That's also pretty cool. And there are other options too, especially if you do deep sky photography, long exposure times, then maybe Nina is the software for you. And I will show you also how the camera works with Nina. So when you connect the camera, it's already recognized here as a ToupTek camera. That long name is from ToupTek itself, so we name the cameras a bit different with shorter names, 2600 for example. So this is the first option you have. That's also the native support. That means no additional drivers, there's no ASCOM involved. The Nina software communicates directly with the camera. That offers you some advantages. For example, you have the full control of the camera within Nina. As you see here, that camera interface shows you all the parameters that the camera offers. Starting from default gain settings, USB control, over conversion modes and so on. The other option, let me just quickly disconnect it again. The other option for these cameras is the ASCOM platform. So ASCOM is definitely a known word to you. With ASCOM you are able to use virtually any software that's out there because nearly any software supports ASCOM. And that is also possible here. Again, on our website you find here ASCOM drivers. This is also the same package for every ToupTek camera, so you just have to install this platform and the ASCOM drivers once to get support for all ToupTek cameras. And when you do that, you can also use, for example, Sequence Generator Pro or MaximDL, if you know that. These softwares are then usable too. And of course also Nina. When you install this driver, then Nina offers you also here under the ASCOM heading, it offers you, for example, here the ASCOM telescope camera, which is this one. And then you can connect it. And what you now see is that here are less parameters adjustable. That is because with ASCOM you can't rely on the software, that the software offers all the parameters to set. So ASCOM has its own settings dialog, which pops up here when you do the ASCOM property selection. Then you can adjust all the things here. So same functionality, it's just a different dialog. Depends on you what you prefer. There's one major issue that I want to mention here. When you have decided for a way to capture, then you should stick to it. So if you use ASCOM interface, then keep using it, or when you use the native drivers, then keep using native drivers. Because they are not compatible in terms of the image size, for example. So the native driver delivers a slightly bigger or smaller image, I'm not sure. So that's not compatible with the ASCOM version. And that leads to the fact that you can't calibrate them. You can't exchange the calibration frames, for example, and that's a pain. So I would recommend stick to one version. Okay, now let's go into some details. With these cameras, with all CMOS cameras, with all the newer generation CMOS cameras, you can set some parameters in the drivers of the camera. And the most important ones are the offset and the gain. So I know there are a couple of videos out there, you should check them out too, but I will try to briefly wrap up what offset and gain means so that you have an idea what to set. The first one, that is the easy one, this is the offset. So this parameter is, let me just quickly go to the different setting here. This offset value is here. This parameter is the offset. And here you can put in a value between 0 and more than 7,000. And this value is just, as the name implies, an offset that is added to every pixel. So why should you do that? The cameras natively cut the image at a black level. So they try to interpolate where black is, and some image information is then clipped. It's just cutted away because it would be a little below 0, which is not possible. So you get a very black image, but that is physically and mathematically especially not correct. What we want to achieve is that we have a value in every pixel, not 0 or also not 1. And that is where the offset come into the game. It's just an added value. So it's the same value for every pixel. For example, let's say 50, then you will have the lowest value in the image of 50, but there are also some values below 50, maybe 48 or 47, something like that. And with these values you can calculate things, you can calibrate your images, you can stack them better together. So it is important to know that value. There are some rules of thumb how to set the offset, but there's also a pretty easy way to test it for yourself, because depending from manufacturer to manufacturer and from sensor to sensor, that value changes. So I would recommend testing it out for yourself. And a very easy way is the following. Let's just capture an image with the cap on the camera, so a real dark frame, but with the shortest possible exposure time. And we try it with 0 seconds. And we use the gain of 0. So that's the first thing that I want to show you. So just grabbing an image. And here we have the histogram. And in this histogram, you see the lowest value here is 0. And as I said, that's a value that we don't want to have. What we want to achieve is, we want to bring the minimum value to anything above 0. That's the idea. Yeah, how to do it? We just go into the settings and use a random value. Let's say random. I would try out 100, for example. Do another shot, 0 seconds, that means practically no exposure, just dark. So what we now see, it's still 0, but only very little values are at 0. That looks pretty good. Let's go with 130. Take another shot. Oh, and here we go. Now we have the minimum value of 19. So that means, unfortunately, it's not possible to see it here in the histogram. The resolution is just not high enough. We can also now go a bit lower, maybe 120. So there's no need to bring it to 1 or 2. Let me explain this to you just in a minute. Let's take another shot. And now we are at 9, of course. And that's good. That's perfect value here to go. We have now signal in all pixels, nothing is clipped anymore, and that's perfect for calibration. So you can just write this value down, 120 for this camera. It's a good value. Okay, now the offset was the easy one. The CMOS cameras, independent from the manufacturer, also offers always the gain setting. And what is this gain setting? Well, you can compare it to the ISO setting in DSLR cameras or in digital cameras, in normal photography cameras. That's some sort of the same thing. It's an amplification of the signal that the camera records. It is a bit more difficult here in these astronomical cameras because you have two basic settings of the readout mode of the gain setting. The first one is the low conversion gain and the second one is the high conversion gain. The low conversion gain means very low amplification of the signal. That leads to a very high full well capacity, for example. Leads also to a pretty flat image, not very noisy. And the most important thing is that you can integrate longer times, especially for LRGB images. That's a good setting because the stars will not blow out so fast. For example, this camera here has a full well capacity of 55,000 electrons in the LCG mode. And another thing with this low conversion gain mode, the readout noise is higher when using that mode. When you read out the image from the camera, there is noise introduced from the electronic when reading out the image. That's a physical fact or an electrical effect. You can't avoid this. And this value is slightly higher. So the good thing is, the LCG mode is mostly used for long exposures. Many seconds or minutes mostly. So this is not a problem. We are talking here about, for example, 3 electrons read noise, which is really a low value. You also won't see this effect in your final images, especially if you expose, let's say, 5 minutes. All the other noise sources that you may have are much higher than that read noise. So don't care too much about that, is my recommendation. In the high conversion gain mode, on the other hand, the signal is already amplified, pretty heavily indeed, and this will lead to a reduced full well capacity. At some point they may be reduced drastically, so you have to check how big the full well capacity is. For example, with this camera here, the value drops to around 20,000 electrons full well capacity. But of course you have amplification. So, well, when to use this mode? Well, a good thing is, what many people do is they use the HCG mode for narrowband imaging. In narrowband imaging you mostly don't have bright stars that maybe blow out when capturing long times, but you have faint signal in your field, in your frame, and you want to bring this up more easily. So with the HCG mode this is not a drawback, that's a real advantage to use this to bring out these faint signals. There's also another advantage with this high conversion gain. The readout noise drops drastically when using this mode. In this example here with this camera, it drops to below 1 electron in read noise, which is next to nothing. That's a great thing, especially when you do EAA, that electronic assisted astronomy, where you do many short exposures. There is that noise that you have because of the amplification, but when you do many images, hundreds of images, and you stack them, the read noise is not an issue because it's virtually gone, and you average out this intrinsic noise in your image and you get a crispy image over time. So that's pretty cool for this mode. Okay, so that's the basic principle of the gain setting. Now it is a bit more complex here because you have an additional setting of the gain. Now, in addition to these 2 readout modes, you have an additional slider for gain, as you see here. And what this does is it changes the gain value in the LCG setting or in the HCG setting. There is maybe a technical overlapping, but you can adjust this slider freely. You can change the gain here in tenths of percent from 100. So 100 is the lowest gain setting, which means virtually 1, up to 100, which means 100% amplification. So that's the idea here. And yeah, you can change this value if you want. Now, my recommendation here, I would recommend not changing the slider. Why? Because it makes things much more difficult. Remember, you have to create calibration libraries, bias frames, maybe dark frames if you want. I will tell you that in a minute. And you have to create calibration frames proper with the exact same setting as your light frames. And when you do many different slider settings here, you have to create calibration frames for all these settings. The advantage is not so high that you have to use it. There's no real need to use this. My recommendation is stick with the lowest setting, that 100, and do just HCG and LCG. That means 2 sets of calibration frames, and that is good to go. There's one exception. If you do this EAA, that electronic assisted astronomy, then it can be useful to crank up that slider in the HCG mode if you want to use real short exposure times. Maybe you want to capture some planetary nebula or something like that. with short exposure times because the tracking is not so good, then you can crank up that value and just try out how that integration works. But for regular deep sky photography, I would not recommend doing it. Okay, one word regarding calibration, because I mentioned that already. My findings were with these newest generation sensors like the 533 or this 2600, they are claimed as noise free. And that is true. The dark noise is not really changing over time. The electronic corrects this so well that I can recommend to skip the dark frame calibration. What you still should do is flat fielding, of course, and bias calibration. For every image, do just a bias calibration, then you have that read noise level removed from the image, which makes image just clearer. That's a good way to go. But yes, I did captures here, many captures with these cameras without dark calibration. So it's working, it's pretty cool. Two more things that I want to show you here, especially here in the Nina software. You have some more parameters to set. For example, here the ultra mode. So it claims that then the read noise is dropped additional. I can't tell you, unfortunately, I can't tell you how this is done. I just don't know it. And I measured it with SharpCap, and yeah, the read noise is reduced a bit by 1 electron or something, but it is already so low that, yeah, just enable that feature. That's okay. There's no problem with that. And the other one is the high full well mode. Well, that sounds interesting, especially when you recall that HCG mode that I mentioned. Here I'm also not sure how ToupTek does it, but I can tell you that with this feature enabled, the full well capacity is nearly doubled. That means 100,000 electrons of full well capacity in the LCG mode. And that is striking awesome. A downside of this feature is that the sensor acts not linear anymore. That means very bright things will just dim a bit, so that's exponential function there, some way like this. It is cool to have this feature, especially if you do just LRGB images and want to produce pretty pictures. That's fine, just use it if you want, or just try it out before and then use it. It should work pretty well. For scientific purposes like astrometry, I would not recommend using this feature because, in my opinion, it will not work if you measure brightness in your images, so then I would not enable this feature. And the last things here are, of course, you can enable or disable the fan. This is not really used, but you have to enable it when enable the cooling, because otherwise that will harm your camera if you disable the fan. And you can also adjust the energy to the dew heater, which is integrated here in the front, which keeps your front glass frost free. Well, that was pretty much information. I hope it was informative for you, that you can take some of the informations and get a better knowledge and understanding how these cameras work and what to set now with your imaging. If you have some photos to share that are taken with ToupTek cameras, feel free to send them to us. That would be super cool if we can feature them somehow on social media. So thank you already much for that. If you have any further questions, comments about the cameras, feel free to drop a comment below the video. Okay, that's all for now for this video. Thank you very much for tuning in and see you next time. Bye bye.